Assalamu alaikum everyone. We're back with yet our first example. In the last video we have discussed the construction of root in locus, and in this video we are actually going to solve an example of how to construct root in locus when we are given certain things. In this question we have to find the root and locus of the system of the following when g of s is given and h of s is given. Okay, as previously we discussed that in the first we have divided it into certain steps, and then uh, we will find out our root and locus. Therefore, step number 1 is we have to find how many poles and how many zeros are there. So as our question is, g of s is equal to k over s into s plus 1 into s plus 2. So this denotes the number of zeros, while these all denotes number of poles. So we have zero number and we have no zeros over here, so number of zeros is equals to 0, while number of poles we have is, this is first pole, that is s minus 0, then this is second, s minus 1, s plus 1 and s plus 2. So we have 3 poles. Okay, next. Okay, the next part that we have to do is step number okay, step number 2. What is that? In the step number 2 we have to find number of asymptotes. And as previously I told you, that is number of poles minus number of zeros. We had 3 poles and 0 zeros, that makes 3. We have 3 of them. Step number 3. Next is angle of asymptotes. As previously I told you its formula, that is theta is equals to 2x plus 1 over p minus z into 180 degree. So x can be 0, 1, 2 depending on the number of poles you have. In this questions we have x is equals to 0, 1 and 2. Okay, and for p minus z, as we have calculated, is 3, so the angles that we are going to get are 60 degree, 180 degree and 300 degree. You can substitute all these you can substitute 0, 1 and 2 respectively, and then you will come to know that you will calculate these 3 angles. Okay, the fourth step. In step number 4 you have to calculate the centroid, and for centroid our formula is summation of real part of poles minus this is minus summation of real part of z divided with p minus z, that is number of poles minus number of zeros. I'm really sorry for this, guys. Okay, Then we have p minus z, that is the poles we had were 0, -1, -2, because that was s minus 0, s minus s plus 1 and s plus 2 is equal to 0. You have to substitute it like this, and then you will have s is equals to 0, s is equals to -1, s is equals to -2. Alright, you have substituted it in this in place of the poles that was for the poles, and then we have 0 number of zeros, and then we have here 3. So our answer will be -1. That is, our centroid is this. Then step number 5 is going to be our breakaway point. For this, you have to calculate the characteristic equation, that is 1 plus gs into h of s is equals to 0. Now, as earlier I showed you the question, and it was gs was k over s into s plus 1 into s plus 2, while h of s was given to be 1 is equals to 0, and our equation will come out to be like this: s cube plus 3s square plus 2s plus k is equals to 0. And then we have to equate it, we have to write it in terms of s and k. We can take k at the left hand side, and our resultant equation will be so this is our equation. Now the next part is, this is part A. Then part 2 of this step is that we have to take the differential of k in terms of s. dk over ds is equals to 3s square plus 6s plus 2. Then we have then third part of the same question is going to be that we have to substitute dk over ds is equals to 0. For this, our equation is 3s square plus 6s plus 2 is equals to 0. Now, by substituting all these equations in the calculator, you can go to calculator, and in your scientific calculators, press the shift button and go to mode, and then you will come you will go to mode, and you will press 5 for equation and choose the third one, and write a, b and c respectively. That is, this is a, this is b, and this is c. That is 3, 6 and 2. Your resultant will be your values for s will be calculated as negative 0.4226, and the other will be s equals to minus 1.5773. These are the values that you are going to get. Since we have calculated our centroid and it is -1, therefore our centroid should be in between 0 and 1. So this will be our value that we have to consider afterwards. Okay, next part is that we have now step number 6. Step number 6, in this you have to find intersection. Sorry for this, it's not visible. Okay, intersection of imaginary axis. That is, our characteristic equation is s cube plus 3s square plus 2s plus k is equals to 0. Now you have to form the root array for this, and I hope you all know about root array. If you do not know about this, so let me know in the comment section below. I will definitely form a video for this. S cube, s square, s, and this is s power 0. So you have to write the 1, 3, 2, k, and this is 0 and 0. Okay, you have to actually find a determinant. That is, for this you will for this value you will be having 6 minus k over 3. That is, you will multiply 3 into 2 minus k into 1 divided by 3. Here you will be having 0, because when 3 is multiplied with 0 and minus 1 into 0 over 3, the answer will be 0 there. Okay, and for k you will just write, for s power 0, as you can see in the characteristic equation, the s power 0 is k, so you will just write it over here. Next you have for what value of k this system will be stable. This will be stable only if when 6 minus k over 3. For this value of k we have to find when this will be this whole value will be greater than 0, and that will be obviously greater than 6. Next we have to write the second order equation. Second order equation from the root array. So for this you will only and only consider this block, that is this, sorry, you will only and only consider this one, because we have to consider only second order. So this will turn out to be, your equation will be 3s square plus k is equals to 0. Alright, 1 minute, 1 and 0, and what you will get here is 3s square plus k is equals to 0, which means that your k is plus minus root 2j. Okay, now it's time for construction of your root and locus. Since we had minus 1, minus 2, minus 3, and 1, 2, and 3, and here we have 1, 2, here we have 1, 2, this is sigma, this is j omega. Since our centroid is here, and we calculated our we have calculated our breakaway point to be negative 0.426. so it will be somewhere here, and our this is 180 degrees. Then let me make this is going to be 60 degree, and this is somewhat going to be 300 degree. Now over here our value would be root 2, and here to root minus root 2, and this is our breakaway point, and this is going to be